Right, in this section, we're looking at the exact trig ratios. These are trig ratios that you eventually have to memorize, okay? And they involve the angles of 30 degrees, 45 degrees, and 60 degrees. And when you do sine, cosine, or tan of any one of these, they can be written in what we call exact form or surd form. So there are two triangles which we generally memorize, or it becomes in your reference sheet later in senior level. So one of them is an isosceles right angle triangle with sides 1 and 1. And in this right angle triangle, the other angles will be 45 and 45 degrees. That's easy to remember because there's two of these numbers and two of these numbers. Okay. Whereas for the other triangle, you have to consider an equilateral triangle with equal sides 2 units long. And at the moment, there is no right angle triangle there, but we can cut it in half like this, and it will generate a right angle triangle. So once we generate that right angle triangle, this 2 on the bottom is going to split into 1 on each side. So we'll call this 1. Okay. And using Pythagorean theorem will allow us to find out what x is here. So x squared equals 2 squared minus 1 squared, which is basically 3. So x equals to root 3. Okay, so I'm just going to write root 3 there. Okay, so actually I'll write it here. Right, so now that we find that, we can now, oh, there's one more thing we've got to find, which is the hypotenuse, right up here. So the hypotenuse here will be basically, if it is x, then x squared is 1 squared plus 1 squared, which is 2, and so x would equal to root 2. Okay, so sine 45, according to this triangle, using any of the 45s there, will be opposite, just 1, of a hypotenuse, which is root 2. Okay, cosine of 45 degrees, using that angle again, will be adjacent, which is 1, over the hypotenuse of root 2. Tan 45 is opposite of adjacent, so that's 1 over 1, which is simply 1. Whereas on the other side, if you wanted to find out what sine 30 is, well, the thing is, we didn't actually put any angles there, but you have to know that in an equilateral triangle, each of these angles are 60. Now, I'm not going to write the top one, but I'll write the bottom ones here. Those are 60 and 60. But if this is 60, that's split into two of the same angles, which are each 30s. Okay, so I'm going to write 30 there. So that's sine 30, according to that right triangle here. Okay, I'll redraw it out so that it's less confusing. There's 1, 60, 90, 30 degrees, 1, 2, and root 3 there. So sine 30, according to the triangle, will be opposite, which is 1, over hypotenuse, which is 2. So that's half. Cosine of 30 would mean, using that angle, we've got the adjacent edge, which is root 3, over hypotenuse of 2. So that's root 3 over 2. Tan 30 would mean it's opposite 30, which is 1, over the adjacent edge, which is root 3. Okay. Sine 60 will be opposite over hypotenuse. So opposite 60 is root 3. Hypotenuse is 2. Cosine of 60 is going to become the adjacent edge of 60 degrees. So it's 1 over hypotenuse, which is 2. Okay, finally, tan 60 is opposite 60, which is root 3, over adjacent to 60 degrees, which is 1. So it's root 3 over 1. And root 3 over 1 is just root 3. So I'm just going to take off that 1 there. Okay, so each of these trig ratios of 45, 30, and 60 are ones that you really have to remember and memorize. Okay, or if you don't memorize it, then there is another way to get on the calculator. Okay, but I will show you that later on. So, question 1a. Find exact value of the priority rule. Okay, so how are you going to find the x here is by relating the opposite edge to 60 degrees and the adjacent edge. So we're going to use tan. So tan of 60 is x over 12. But we know tan 60 according to what we just have here. Okay, tan 60 is root 3. So we're going to write root 3 here equals x over 12. And by simply multiplying 12 to both sides, we'll get 12 root 3 equals x. For question B, we've got the angle 30 here. Okay, we've also got opposite and the hypotenuse. So we're going to use the sine ratio. So sine of 30 equals to 20 over x. Now you know sine 30 is equal to half. So we're going to replace that by half. That's equal to 20 over x. Now if you cross multiply, then 1 times x is x, and 2 times 20 is 40. Okay? C. You've got an angle here. Adjacent to that is m, and the hypotenuse is 4. Okay, so that cosine of 45 is equal to m over 4. Cosine of 45 is 1 over root 2. So 1 over root 2 equals to m over 4. And if we multiply 4 over, then you just get 4 over root 2 equals to m. For question D, we've got the adjacent edge here, which is root 3, and the hypotenuse. So that relates to cosine theta. Okay, so cosine theta is now the adjacent edge, which is root 3 over 2. This time, though, what we're going to do here is just write theta equals inverse cosine of root 3 over 2, which without a calculator, you can actually find out of this lot here. So the angle that you need is going to be 30, which is root 3 over 2. So theta is simply 30 degrees. Okay. Right. Last question. In E, we've got the opposite edge and the adjacent edge. So that relates to tan theta. So tan theta is opposite, which is 3, over adjacent edge, which is root 3. Now, remember you've already learnt how to rationalize before in surds, just by multiplying the top and bottom by root 3. This will give you 3 root 3 over 3, where the 3's cancel. So that tan theta will now equal to root 3. Now, where is tan theta equal to root 3? You can do this in your calculator by doing theta equals inverse tan of 3. The other way is to look over here and find which angle do you apply tan ratio to get root 3, which is this one here. So that's just 60 degrees. Okay, so that means theta equals 60 degrees. Okay, right. So back to what I was saying about doing this on your calculator. Okay, so if you can't memorize these, there's a simple way of doing this in your calculator. I'll show you it using sine 45 degrees. So when you type sine 45 on your calculator, type out a sine 45, but square it. When you square it, you will get half. This is the only time where you would use your calculator for this. Now you just have to use your brain and take the square root of both sides. If you square it both sides, then you get sine 45 on the left, and taking the square root of this will get you 1. If you square it 1, it's 1. And if you square it 2, it's just root 2. Okay, that's how you get that one. Another way, another one I can show you is maybe this one. okay, cosine of 30. So cosine of 30 squared on your calculator is 3/4. If you take the square root of each one of these, then it will be root 3, because you can't square root 3 and to get a integer, but you can square root the 4, get you a 2. Okay, and that's how you get that answer. All right. So that's a trick of using the calculator to find that. Okay, I hope that helps you.